so today's topic will be the jumping rabbits. These are the standards, and if I could have somebody read the learning objective.
Alright. The learning objective. Given a real world situation, I can write an equation, I can graph an equation, I can label and scale the axes appropriately.
Thanks, Sam. Alright, so I gave you guys 2 questions here, so you guys can start working on the warm-up. So this is something that we did last class. So I want you guys to take this equation and convert it from the standard form into graphing form. And I'll give you guys a couple minutes. For those of you that forgot, so by show of hands, who's stuck here? Who needs a little bit of help? Show of hands. Higher. Okay. So let me rewrite this. So right now we have the equation in form of, or actually it's in standard form. So who remembers how to complete the square? Completing the square. Good. So what's the first step when you complete the square?
Subtract 9 from both sides.
Yeah, so let's do that. So now I have y minus 9 is equal to m squared plus 6m. And then I'm just going to include a box here, so I'll write plus a box, plus a box. Does anybody remember what goes inside that box?
B, you have to take B and divide it by 2 squared.
Good, so let me actually.
So it'll be 6 divided by 2 squared, and 3 squared is 9.
Yeah. So there is a box. So again, Tim, how did we get the number inside the box?
So it's B divided by 2 and all of that squared. So in this case, it'll be 6 divided by 2.
So 6 divided by 2. And then you square it, right?
Yeah. So 6 divided by 2 is 3, and then 3 squared is 9.
So what's the number that goes inside the box?
9.
9. So once we have it in that form, now this becomes a perfect square. So what would be the simplified form for this? For that side?
You will add 9 plus 9, right? Or minus
Oh,
9?
Yeah, you can do
so
that.
that automatically crosses out, so it's just going to be y is equal to
So that goes to 0. So y equals
m plus 3 squared, I believe.
m plus 3. Good. So when it's in this form, how can I use that equation to determine the vertex? So let's pretend that I didn't get rid of that 0, and I'll just place it here. So now I want you guys to take some time and try to determine the vertex, and then once you determine it, write on the whiteboard and show me your answer. So you're finding the vertex right now.
One's going to be negative 3, 3, I think.
You guys are almost right. It's like a combination of those two.
Is it, where's the 3 0?
3, because it's 1.
Yeah, right.
Yeah.
Alright, so if you have an answer, please raise up your whiteboard. Good job. Good job. Almost. Okay, so the vertex for this problem should have been, And it's really easy once you have it in graphing form. All you have to do is take the opposite of that value, so that's, let me write the graphing form again for you guys. Squared plus k. So that means that, what's my h value for this one?
3. Positive 3.
But you always wanna take the opposite of it, so
Negative.
-3, and what's my k for that one? 0. So this here is your vertex. Any questions on that?
We got it.
Okay.
Is that it for the warm up?
That's it. Mm-hmm.
Planes as you can on your sketch. Explore using 2-64.
Alright, so I put you guys in groups of 2, so I want you guys to click on the link, and you guys should have access to the link.
Alright.
So your link should look something like this. So it looks really big right now, but let me zoom out. And what I want you guys to do in your small groups, I want you guys to discuss about so what has to be true about this picture? Can it be placed here? And that's something we kind of went over in the beginning. So, and the way you move it around is by changing your A and your B value. So you could shift your bunny around. So do that with your partner, please. And on the PowerPoint I provided you guys could also, I want you guys to answer these questions as you're working through the problem. So these are discussion points that you should be talking to with your partner.
So I know it has to be in the first quadrant, right? She said, so it has to be both positive.
The shape of the jump?
Yeah, so exactly.
are
If we look
we-
at the first one, it's saying, what is the shape of the path of the jackrabbit? Just by looking at it, what do you guys think?
It's hitting over.
It's going,
Right side.
it's positive, right?
It's positive, what else? What shape is it? What's the shape of the path as the rabbit is jumping?
Kind of round, isn't it?
Roundish.
Half a circle.
Okay, so when we're talking about graphs, what kind of graph is that similar to?
Oh man.
It's not half a circle, right?
That one graph that shows
Oh, parabola.
Perfect, yeah, so
Yeah, right.
if you go back to if you guys look at your bunny picture that you guys have there, it's gonna be a shape of a parabola, right? So it's like, it's jumping, but it's not gonna be a full half circle. So right here, in your group, you would write parabola. And when we're talking about parabolas, usually what type of equation are we looking at?
X squared.
Which is?
Y equals x squared. Or what?
Good, yeah, that's a parent function,
Wait,
but
can you repeat that?
what type of equation would we be looking at? So what type of equation models the situation? Carla was correct, she said y is equal to x squared, right? That's a parent function of the parabola. But what specific
Square root of x squared.
would be
Quadratic?
perfect, quadratic. So you guys are looking at quadratic equations. So these are the other two questions that you guys have to answer with your group. So you guys are your job is to move around the bunny. You're gonna determine the h and the k, and then you will find the value of a. Any questions?
So do we start off with the parent function?
Yeah,
And
you
then
could do
work
that.
our way
what was
from
the
there?
parent function?
Y.
Is
So
y
it all
equal to-
depends on where you place your bunny. So that's what I want you guys to do right now. You guys are
Okay.
gonna move around the bunny, place it on the x and y axis, and you guys are gonna try to determine the vertex and the a.
Nice.
Okay? Any questions? No? You guys are good?
Wait, so it doesn't matter the position that the bunny is in because we moved it in this specific picture. Or do we have to keep it in the first quadrant?
Let's see. So why'd you place the bunny there?
Just because it was following the numbers on 3 feet, and then also because it had to be in the first quadrant.
Okay. So
because we didn't know if we could just put it anywhere in the first quadrant.
You
and
could
just
place
mess
it
with
anywhere in the first quadrant. So personally, the initial value I would choose to place a bunny would be 0.
Just because it's easier, right?
Just because it would make it easier for me. Alright guys, one more thing. So just by looking at that image of the bunny, what is my, can you guys determine the vertex just by looking at the picture?
3, 0.
Yeah, it's 3, 3 and 8, no?
3, 0.
What?
The initial value is 0. Let's put it like that.
Can I see, Tim? Let me see what you have.
Those? You want me to put those two in there? Okay.
Okay, so the reason, okay, so this wouldn't work, right?
Yeah, because it's not where it's supposed to be.
So another way you could think about this is think about this as a ground, right?
Mm-hmm.
So right here you're telling me that the bunny is jumping
Negatively.
negatively, yeah.
Which is not supposed to.
Yeah.
Okay. So in that case, I'll move this up and it would be like on 0 right there. Or is the first line right here 0?
You don't specifically, because you don't specifically have to start at a negative y value, a negative x value, sorry. You could shift it and make it start at 0. That would be your initial value.
Okay, so in that case, it would be where the bunny starts off jumping, right?
Yeah.
Okay.
Alright, so okay. So let me actually go back to this picture. So this is the picture you guys were looking at. I'm gonna choose to make my bunny start jumping at 0.
Mm-hmm.
And in the positive y value section, so it's gonna be here. Alright, so one of the questions I asked you guys was to determine the vertex, right? What is vertex again? Vertex. What does vertex
Since it is the point, right? Like for example, a parabola, where it started.
Like,
You're on the right track.
like I
The
know.
point, the middle point of it, right? In the middle.
Good.
Yeah, basically. Where
point when
the
it
where the
starts going.
axis of like
Symmetry.
symmetry like cuts it in half, like
Yeah.
that point where.
The line of symmetry, yes. Anybody else? So if I told you here's my, that's my vertex, right?
Yeah.
So what does that point represent on the graph?
Means that it's going down.
The highest point it reached.
It's the highest point, right? Your vertex, which is HK, represents the highest, it could be the highest or lowest point. On the parabola, right? So it's your highest or the lowest point on the parabola. So what's the height that that bunny is reaching?
3
3
feet.
feet.
3 feet. So does that represent my x or my y value? And why?
Your y, because it's going upward, so vertically on.
Vertically, so exactly. That represents my y. What would represent my x?
8 feet.
Are you sure?
No.
Think about it. What did we say? You kept mentioning that your line of symmetry for vertex, right?
Mhm.
What does the line of symmetry tell you?
It's 4, no?
It's basically.
Let's take half of 8.
Perfect. Yeah, it was 4.
Oh, no.
So that there is your vertex for this problem. And the reason why is because you were right. So the vertex, you could actually find your line of symmetry because it's where it's split down the middle, right?
Mhm.
So that's the reason why we also have to divide this value by 2 to get our x, your horizontal distance. And that's kind of what we're actually gonna do an activity. It's a water balloon activity. And I'm gonna give you guys an arbitrary height and you guys are gonna have to find the horizontal distance. So you guys are gonna repeat the same process, just different heights. Okay?
Got it.
Alright,
Nice.
cool.